Section 1.2 covers a variety of topics, but in this particular video, we're going to look at angle relationships and vertical angles. Many of these you've already studied in high school, but we're going to review them and then we're going to apply them to problems. Note really quickly that of the 5 listed, vertical angles, alternate interior, alternate exterior, and corresponding all have equal measures. Interior angles on the same side, number 4, is a little bit different, but we'll look at that as we get there. Also, remember from geometry that parallel lines lie in the same plane and they do not intersect. The first example of angle relationships we're going to observe is the vertical angles. As listed here, I'm going to number that number 1 so that you know exactly what I'm talking about in the video. Angle QMR, that would be this one right here, and angle NMP, the one highlighted in blue, are vertical angles. It's basically one angle that is extended through its vertex to create another angle, and they do share that common vertex point of M. Vertical angles are equal in measure, so their measure is equal, and we will use that in a few problems later. Their measures, plural, equal. Okay, for the next example and definition we have parallel lines M and N, that are cut by a transversal Q. Transversal is just letting you know that it does cut those parallel lines. And we're going to look at the remaining 4 relationship of angles through this particular illustration. The first type we're going to look at are alternate interior angles. Now, alternate, by definition, means that the angles are going to be on opposite sides of that transversal. So, for example, angle 2 and angle 3 are considered alternate, or angle 1 and angle 8 are considered alternate because they're on opposite sides of the transversal. But we also want these to be interior. By interior, we mean between the parallel lines. So an example of alternate interior angles would be angle 4 and angle 5. They're on opposite sides of that transversal, but they're both within the parallel lines. These two angles do have equal measures as well. The next topic is alternate exterior. Well, by alternate, we still mean on opposite sides of the transversal. And exterior means they need to be outside those parallel lines. So angle 1 and angle 8 are alternate exterior angles, and they are equal in measure as well. Now I'm going to skip the interior angles on the same side of the transversal for just a minute, and I'm going to go on to corresponding angles. Corresponding angles are sitting in the same place relative to the parallel lines in the transversal. For example, angle 2 and angle 6 are corresponding. They are equal in measure as well, but the reason they're corresponding is because both of those angles sit above their parallel line, and both of those angles sit to the right of the transversal. So they're corresponding into the same relative position in relation to those parallel lines and that transversal, and they are equal in measure. Notice all of the angles we've covered thus far: vertical, alternate interior, alternate exterior, and corresponding. All of them, the angles have equivalent values when their measures are compared. Now let's look at that last relationship, the interior angles on the same side of the transversal. So we'll just call that interior same side for sake of writing. Obviously, interior means they need to be between the parallel lines, and the same side means the same side of the transversal. So an example of that would be angle 6 and angle 4. Now notice I'm not setting them equal. Take a look at those angles. 6 looks acute, whereas 4 looks to be obtuse. So they do not equal in measure. What you will find is that these are supplementary, particularly angle 4 added with angle 6 will make a straight line or a straight angle will equal 180 degrees. So these are supplementary angles. And I hope by now you have figured out what supplementary is. They add to 180 degrees. Now those are the 5 relationships that we're going to look at between angles. We're going to spend the next exercise and then the next video working a couple of problems using these principles. So let's move on to page 2. And I want to find the measure of each marked angle given that my lines M and N are parallel. It's very important that you give this information that they're parallel, or otherwise we can't deduce these properties from it. So I'm looking at this angle here and this angle here. They are both between my parallel lines, so they are interior. And in relation to my transversal, they're on the same side. So these are same side interior, and what I know based on my last rule is that they should add up to 180 degrees. That is x plus 1 degrees and the 4x minus 56 degrees should add up to equal 180 degrees. Now in order to find the actual measure of these angles, I need to find out what x is. So the parentheses are not highly important. This will give me 5x minus 55 degrees equal to 180 degrees. Adding the 55 to both sides, I will get 235 degrees, doing a little bit of this in my head, so bear with me. And dividing by 5, I will get 47 degrees for x. This is not the answer to my question. Go back and problem solve. If one of my angles is x plus 1 degrees, and we now know that that x value is 47, and I know that one of my angles is 48 degrees. Now you can do this one of 2 ways. You can subtract that 48 from the 180 degrees that they have to sum to get your second measure, or you can substitute into the next problem. I will do both. So if I take 4x minus 56 degrees and I substitute the 47 in 4, I'm gonna really quickly rewrite this because I just don't like the way that was written. Go on the outside. Then 188 minus 56, I will see that this becomes 132 degrees. And to check myself, just to check, does 48 and 132 degrees add to 180? It does, so I know that this is my answer and this is my answer.